This e-learning provides important information for the measurement of the redox voltage. The redox potential determines the tendency of substances to take up or release electrons. For example, substance A has a certain redox potential and will take electrons away from substances with lower redox potential. The redox potential refers to that of hydrogen. Due to the existing reference potential, it is called redox voltage. A substance with higher redox voltage takes electrons from substance A. Substance B oxidizes substance A and is its oxidizing agent. Substance A is oxidized and substance B is reduced. The process of electron transfer is called redox reaction. For the disinfection of swimming pool water, chlorine is added. The free chlorine increases the redox voltage of the water. It has an oxidizing effect. The graph shows the redox voltage as a function of the chlorine concentration. Germs are only viable in media with relatively low redox voltage. A too high voltage disturbs their metabolism and they die. For successful disinfection, a chlorine concentration of 0.3 to 0.6 mg per liter is set in the swimming pool water. Possible pollution in the bath water has a reducing effect. It lowers the redox voltage. If the redox voltage is too low, this indicates contamination and the disinfection process is not effective. In this case, countermeasures must be taken, such as a partial water change and cleaning of the filter systems. Combination electrodes are used to measure the redox voltage. The electrodes contain the measuring system, which consists of a metal cap made of platinum or gold. The measuring signal is conducted via the internal conduction system to the plug contacts. Furthermore, the reference system creates a reference potential independent of the redox voltage. The reference system is opened via the diaphragm, and in it there is a reference electrolyte of potassium chloride. The reference potential reaches the connector via the reference conduction system. The electrodes with ceramic diaphragm are used in clean media. Contaminated media require the use of PTFE diaphragms. For media with extreme contamination, electrodes with open diaphragms such as hole or annular gap diaphragm are used. The electrodes are connected to the transmitter via coaxial cables. The connection is made via the two-pole N connection system. The figure shows the connection of the combination electrode to the analysis input 1 of the Jumo Aquis Touch P multi-channel device. The inner core of the coaxial cable carries the potential of the measuring system, the shielding that of the reference system. The standard wiring shown corresponds to the asymmetrical connection. This requires a factory-fitted short-circuit bridge. The transmitters can be configured via a program. However, the few settings required for the example are made via the front panel. With regard to the electrode type, the setting for the redox voltage electrode must be made. Slope changes do not occur with the electrodes for redox voltage. An existing zero-point shift, or one that occurs over the operating time, is compensated by a zero-point calibration. The calibration routine is released. The measuring circuit is tested with a test solution. It is important that the metal and the diaphragm are in the solution. The transmitter must indicate the redox voltage specified on the vessel. The test solution produces different redox voltages for electrodes with or without salt reserve. The salt reserve consists of recognizable salt rings in the reference system. If the measured value reaches its final value very slowly, the reason may be the passivation of the metal. The passivation is counteracted by treating the metal surface, for example by polishing with a cloth or using cleaning agents. If the measurement in the test solution shows deviations, this is corrected by a 0-point calibration. During calibration, the redox voltage of the test solution must be defined. The transmitter shows a 0-point deviation of the combination electrode. Calibration is taken over. All calibrations are documented in the calibration logbook. After calibration, the electrode is ready for use. The electrode must be kept clean during the operation time, and the measuring circuit must be checked regularly. All information about our seminars, webinars, e-learnings and reference books are available on our homepage.